Okay, so my name is Sean Kelly. I'm a meteorology student. I actually just came from doing some forecasts, so I partially undressed like this. So my presentation is on an effective climate change mitigation method to enhance snow depth on ski resorts. And it's mostly directed to Mr. Riley, who's president of the Vermont Ski Areas Association. He is a lobbyist who has renewed legislation in which helps promote Vermont as a destination for international visitors, and he is in part responsible for the success in increasing revenues to the resorts. And I'm going to tell you about a problem in which puts all of his hard work at risk. So the overview of what I'm going to discuss is, first, before I go into the problem, I'm going to talk about the relationship between ski resorts and the local economy. I'm going to establish the problem, talk about weather modification and specifically cloud seeding and how it works, some successful models, plan of action, and then the cost. So, to start, Vermont's economy is strongly linked to the ski resorts that are embedded with it, because it's the largest skiing state on the East Coast. In winter months, recreation options are more confined to winter-related recreation, and this puts more pressure on ski resorts to do well, to get as many tourists to come and ski, and all the advertisements that go with that. So Vermont ski resorts alone support over 30,000 jobs, and ski tourism not only contributes to the finances of the resorts alone, but it contributes to the surrounding businesses. So it's a lot of things at play there. And according to the Vermont Department of Tourism, tourism contributed over $1.7 billion to the economic activity of Vermont, and this was upheld by Mr. Riley. So I'm going to talk to you about a problem that puts all of this prosperity of Vermont at risk. And the problem is global warming and climate change. And first, I want to tell you that global warming and climate change, they are not interchangeable. I don't care what anyone else tells you. Global warming is a characteristic of climate change. According to the Intergovernmental Panel on Climate Change, IPCC, studies indicate a global average temperature rise of 0.85 degrees Celsius in the last 2 decades. So before I tell you how they got this data, I'll tell you a little about the IPCC. They're a group of thousands across the world, 120 nations, and they constantly release updated peer-reviewed reports on current conditions of the climate. Okay, so they're also volunteers. They're doing this without payment, so they're not being funded by the oil companies. They have no reason to skew the data. So this graph right here is called the hockey stick model, because of how it's oriented. So you can see that by the 80s and past, there's just an unprecedented rate of change is unprecedented. The magnitude is unprecedented. And before the 80s is when we didn't have satellite data. Before satellite era, we had to do other forms of methods to obtain data. It's called proxy data, which is basically, the definition is any preserved natural entity that expresses like the current characteristics of that time period. So like ice core samples, tree rings. Ice cores, for example, when ice melts and then refreezes, it grabs oxygen in the air from that time, and that can tell us about all the characteristics, the temperature, all the good stuff at that period. So the IPCC takes all that data, they extrapolate it, and they graph it here. And you can see the spread in the data as you go further back. There's actually different organizations who were skeptical of this. They saw this and like, oh, there's no way that this rate was seen like no other. But different organizations came together, they interpreted their own proxy data, and they came out with this, and they're generally pretty good consensus right here. So what is it that is making this current change over the past few decades like no other? Is it natural variability? There's two different things. There's volcano activity, there's solar activity. Volcanoes, actually, when they erupt, they block the sun, so they would actually cool the earth. And you can see right here is actually a mini ice age we had in the 1800s, and you can see that it's strongly correlated with a bunch of volcanoes that erupted. What we actually see in the next table here is that volcano activity has actually been on the rise. So we should be seeing a decrease in temperatures right now, but we're not. So you got to cut that out of the equation. It can't be volcanic activity. So is it solar activity? Is it sunspots? What we actually did in class, myself as well as my professor and a bunch of other students, we calculated, using this big old equation I will not write down for you, the change in the intensity of the radiance of the sun with fluctuations in solar activity, and it turns out that there's only a difference of 0.5 watts per meter squared, and that has minimal impacts on the global temperature, does absolutely nothing, so you can rule out natural variability. So what is it? So the IPCC confirmed that it is rise in CO2 emissions. This is plotted with help from the Mauna Loa Observatory in Hawaii, which takes the amount of CO2 concentration in the atmosphere, and you can see it plotted here, and it's strongly correlated with global temperature. So as CO2 emissions continue to rise, the global temperature will rise right along with it, and right now it's at a rate never seen before, and we need to make some changes. So with that being said, the rise in temperature across the country and the globe equates, specifically for Vermont's situation, which we'll be talking about, creates deteriorating ski conditions, and therefore a decline in Vermont's economy, because I showed you that relationship. So what do we do about this? Well, Mr. Riley, he's just one person. He can't just, we can't just stop the total CO2 emissions, with the snap of your thumb. But what he can do, especially in the position he is, he's a lobbyist, we can help propose legislation in which can at least help mitigate these negative implications that will soon occur in the state of Vermont. Or else, if we do absolutely nothing, all this hard work will be at risk. So what is one of the solutions? One of the solutions is called weather modification. We do cloud seeding. We've been doing this for many decades all across the world. There's two different ways you can do it, through ground generators and through airplanes. For the sake of this, we'll talk about ground generators because they're cheaper, they're more practical. And what they do, well, basically, first of all, I'll talk to you about some basic meteorology, physics of how precipitation forms. Water vapor in clouds, when you see clouds, doesn't necessarily all have precipitation. They need some nuclei to condense onto. So that could be salt from the ocean that goes in the atmosphere, dust from like a desert or something, or just regular pollutants. And those all act as nuclei in which the vapor condenses onto, and then through a bunch of different processes, the raindrops will grow, and then when it overcomes gravity, it will fall to the ground. So, so that is one solution that we could do, and some studies they did.